The topic for today's video is trigonometric ratios. Trigonometric ratios and trigonometric functions play a very important role in many areas of mathematics, physics, chemistry, engineering, and other applied areas. The background that is needed for understanding and working reasonably well with trigonometric ratios is as follows: algebraic fractions and operations with them, because without this it will hardly be possible to look at rearrangements and manipulations that you need to do with trigonometric identities and trigonometric functions. Since trigonometric ratios are defined on the basis of right angle triangle, basic familiarity with right angle triangle is a must. Basic property that sum of all internal angles of a triangle comes in handy when we are dealing with relations between different trigonometric ratios. Solving linear equations in one unknown is needed to find out and solve equations. Basic facts about congruence of triangles will be needed. Basic facts about equilateral and isosceles triangles will also be needed. And of course, finally, the Pythagoras theorem, which means basic familiarity with right angle theorem. I'm specially emphasizing Pythagoras theorem because most of the relationships between the trigonometric ratios are derived on basis of the Pythagoras theorem. Let us look at the angles in a right angle triangle. Suppose one angle is x, which is different from the 90 degrees, that is the right angle. Then the other angle would be 90 minus x, because the sum of all internal angles of a triangle is 180. This follows. Now the side opposite to angle ACB is side AB. So side opposite to angle X is AB and side adjacent to angle X is BC. Similarly, side opposite to angle 90 minus X is BC and side adjacent to angle 90 minus X is side AB. We do not have a side uh, defined as adjacent side to the right angle. AC is the hypotenuse. Restatement of Pythagoras theorem. Normally we state the Pythagoras theorem for a right angle triangle ABC shown in the figure as AB square plus BC square is equal to AC square. We will just restate it in the form opposite side square plus adjacent side square is equal to hypotenuse square when we are dealing with an angle. So side opposite to an angle its square plus side adjacent to an angle square equals the square of the hypotenuse is the statement that we will need when we are dealing with the trigonometric ratios. The most important thing about trigonometric ratios is, as we have discussed earlier, they are defined for angles of right angle triangle. So the first of the ratios, called sine of an angle, is defined as sine of the angle x equals the opposite side to x, that is AB, upon the hypotenuse AC. So this is what is sine of x. Similarly, sine of the angle 90 minus x would be BC upon AC, and this gives us sine of 90 equals AC upon AC, because the sine opposite to angle 90 is the hypotenuse. So this automatically gives us the ratio sine 90 equals 1. The next ratio of importance is the cosine of angle. So the cosine of an angle x is defined as the side adjacent to it upon the hypotenuse. So cos x is equal to BC by AC. Notice that this is also same as sine of 90 minus x, because we, as saw earlier, sine of 90 minus x is also BC by AC, opposite side by hypotenuse by definition. On similar lines, cos of 90 minus x would be equal to AB by AC, which is also equal to sine of x. So the relationship between the cosine and sine of the angle and its supplementary angle, its complementary angle, that is the angle which adds to uh, the sum 90. So cos of 90 minus x is sine of x, and sine of 90 minus x is cos of x. Notice also that since AB square plus BC square equals AC square by Pythagoras theorem, if you divide this by AC square, you will get sine square x plus cos square x is equal to 1, which is also same as sine square of 90 minus x cos 90 minus x whole square, that these two add to 1. One of the consequences of this is cos of 90 is defined to be 0, because sine of 90 is 1, so cos of 90 is equals 0. The next ratio, trigonometric ratio, is called cosecant. So cosecant of x is defined to be hypotenuse upon the opposite side to angle x. So here it is in the figure AB and AC. So AC upon AB, which is also equal to 1 over sine of x, because sine of x was AB upon AC. So 1 divided by AB upon AC would give us the AC upon AB. Similarly, cosec of 90 minus x equals 1 over sine of 90 minus x. Now, since the relationship between sine x and sine 90 minus x is there, so this is equal to cosec of x is equal to 1 over cos of 90 minus x, and cosec of 90 minus x equals 1 over cos of x. Cosec is also written as cosec of x instead of CSCx. So CSC is pronounced cosec. It's a short form of cosec, cosecant, and this is uh, written in these two ways. The fourth ratio of importance is secant of an angle of a right angle triangle. So secant of x is defined as the hypotenuse upon the adjacent side, which is equal to 1 over cos of x in this case. Also notice that since cos of x is equal to sine of 90 minus x, this would be equal to 1 over sine of 90 minus x. Similarly, sec of secant of 90 minus x equals AC upon AB, which equal to 1 over sine of x, since it is equal to 1 over cos of 90 minus x. As cos of x is 0 for x equal to 90, so secant of angle 90 equals infinity. The fifth ratio is tangent of an angle of right angle triangle. So we'll define tan of x, tangent of x, to be equal to b upon bc, which is equal to sine of x upon cos of x. So it is the opposite side upon adjacent side is that ratio is called tangent of x. This ratio is quite important as it occurs at many places in physics also during calculation. So tangent of 90 minus x is BC by AB, which is sine of 90 minus x upon cos of 90 minus x, which is also going to be equal to cos of x upon sine of x. Notice that tangent of 90 is infinity because sine of 90 is 1 and cos of 90 is 0. So 1 over 0 we normally call infinity in this case. The last ratio that we are going to consider is cotangent of angle of a right angle triangle. So cotangent, also short form denoted as cot of x, equals BC upon AB, that is the adjacent side upon opposite side. It's exactly opposite ratio of tangent. So 1 upon tan of x will be cot of x, which is equal to cos of x upon sine of x, which is tangent of 90 minus x. Similarly, cotangent of 90 minus x equals AB by BC, which is going to be cos 90 minus x upon sine of 90 minus x, which is equal to tan of x. Cot of 90 is 0 because cos of 90 is 0 and sine of 90 is 1. So we have cotangent of 90 as 0. The Pythagoras theorem is the principal theorem which gives us all these relationships between various trigonometric ratios. Because if you look at the Pythagoras theorem, it says that AB square plus BC square is equal to AC square in the context of the drawn triangle. So sine of x whole square plus cos of x whole square will be equal to hypotenuse square upon hypotenuse square, which will be equal to 1. This we had seen previously also. Sine square x plus cos square x is equal to 1. Now sine of x whole square is written as sine square of x. We pronounce it as sine square x. When we write cos square x, what we mean is cos of x whole square, the square of the cos of x. 1 plus tangent square of x is equal to sec square of x. Now this follows because if you divide the first one by cos square x, you get sine square x upon cos square x, which is tan square x plus 1 is equal to 1 upon cos square x, which is sec square x. 1 upon cos x is sec x, as we saw previously in this video. On similar lines, we will get 1 plus cot square x is equal to cosec square x. So, to repeat the symbolism, sine raised to nx or cos raised to nx or tan raised to nx, what we mean is sin x raised to n, cos x raised to n, etc. The trigonometric ratios of 30, 60 and 90 degrees are required very frequently. We have already seen how the trigonometric ratios of 90 degrees are. Now, in order to be able to calculate the trigonometric ratios of 30 and 60 degree angles, we rely on the equilateral triangle with side 1. If we drop a perpendicular from A, we know that it is bisector of the side BC. In the equilateral triangle, the perpendicular drawn from any vertex to the opposite side bisects that side, because for equilateral triangle, the perpendicular or dropped from a vertex is same as the median. So you have uh, the sine of 30 as 1 by 2 upon 1. So sine 30 will be half. Sine of 60 will be root 3 by 2. This side root 3 by 2 is obtained through uh, the Pythagoras use of Pythagoras theorem, and sine of 90 is 1. So based on these and the relationships, you can calculate all the other ratios. So for example, cos of 30 is immediately known as root 3 by 2. Sine of 30, the sine of 60 is also known immediately as root 3 by 2, because AC is 1, the hypotenuse being 1. The trigonometric ratio of the 45 degrees angle are calculated on the basis of the isosceles right angle triangle with the two sides being 1. So hypotenuse by Pythagoras theorem can be calculated to be square root of 2. Sine of 45 degrees will be 1 over square root 2. Cos 45 will be 1 over square root 2. Using these two values, you can calculate all other values using the previously given expressions in the video. There is more to come. Please stay subscribed, and thank you for watching.